Welcome to the Atoms Project by Jack Rothschild, Mehul Ketchapal, Miss Freed, Chemistry, Period 6.
Hi everybody. So we're going to be talking about atoms in the periodic table. But before we start on that, there are a couple of basic things we need to know. About chemistry. The first thing is an element. An element is a substance that only contains one type of an atom. For example, the gas hydrogen only contains one type of an atom. Thus, it is an element. A compound, however, is a chemically joined substance which contains two or more different particles or elements in them. For example, pure water, the stuff we drink, contains two chemically joined elements, hydrogen and oxygen.
Hydrogen is by far the most abundant element on Earth. It makes up for 75% of all the elements. The other two common elements would be helium and oxygen. Together, these elements make up for 99% of all the elements on Earth. The other 115 fill up just 1%.
So there are three major components of an atom that one must know about: the electron, the proton, and the neutron. As you can see, the neutron and the proton are stuck in the middle inside of what we call a nucleus. The stuff revolving around it are the electrons, which revolve around the nucleus in orbitals. This diagram mainly shows that the orbitals are not perfectly circular and revolve around in many different shapes. So a proton is a positively charged subatomic particle with a mass of 1 AMU and a charge of +1. To find the total protons in an element, you just look at the atomic number of the atomic number above the symbol on the periodic table, and that will tell you how many protons there are in an atom of that particular element.
An electron is a negatively charged subatomic particle with a charge of -1 and a mass of 0.005 AMU. The electron revolves around the nucleus in imaginary shells or energy levels. Each energy level contains a certain amount of electrons, the first holding 2 and the second 8, etc. The electrons revolve around the protons in particular, as it has a positive charge. And as we all know, negative and positive materials always attract, hence the atom is kept compact. The amount of electrons in an atom is actually equal to the amount of protons, so it's also the atomic number.
A neutron is a subatomic particle that was stuck next to the proton, as I showed you before, but it has a completely neutral charge, but with a mass of 1 AMU. So that means a mass of 1 AMU must equal to 1 neutron. Therefore, if we want to find out the number of neutrons, we simply look at its atomic number, and we simply look at its atomic number of an element and subtract it from the atomic mass, thus leaving us with only the number of neutrons in an atom.
Here is the element krypton as you would find it in the periodic table. The symbol for krypton is K, and the atomic number is 36, so it has 36 protons.
And 36 electrons.
Krypton's atomic mass is 83.8, but that's generally rounded up to 84.
So this means that the
amount of neutrons
the amount of neutrons in an atom is 44, because if we take 84 minus and subtract it, if we take 36 and subtract it from 84, we get 44, which means there are 44 neutrons present in this atom.
The main differences between the elements, apart from the obvious physical differences, are the amount of protons and electrons it contains. What differs one out by gaining or losing an extra atom or containing one more proton can drastically change the properties of that atom, thus affecting the property of the entire element or substance it is attached to.
Sorry, I just want to clarify something. By gaining or losing an extra electron, not an extra atom.
Right.
I think we made a mistake over
Yeah.
Isotopes. Isotopes are variants of an atom of the same elements, which are called isotopes. The factors that vary is the number of neutrons it contains. Thus, they have different atomic masses and different physical properties, like look, smell, etc. Every element contains one or more isotopes. Isotopes have many causes. Some may occur naturally, some may occur due to the decay and instability of an atom, thus creating a radioactive isotope. Or it might be created artificially in a laboratory. Isotopes are labeled as shown in this picture. The element symbol in the middle, the atomic number at the bottom, and the atomic mass at the top, as the atomic mass varies. This is an example of hydrogen. This is an example of some isotopes of hydrogen containing 1, 2, or no neutrons, or no neutrons.
This is the periodic table. The periodic table, which originated from a man named Dmitry Mendeleev, is a chart that shows all of the elements that we have discovered on Earth. The periodic table is arranged in rows according to their atomic number. Each elements next to each other differ by 1 in their atomic number. The periodic table also helps us identify the metal and non-metal elements. All elements on the left of the staircase are metal, and the right are non-metals. All the elements touching the elements on both sides are metalloids. Metals are generally shiny, dense, high conductors, and have good ductility, good malleability, and have high melting and boiling points. One way metals can be used is by conducting electricity, and one famous metal that this is used for is copper. Non-metals, on the right side of the staircase, are usually liquids and gases at room temperature. They're usually dull, have low density, cannot conduct heat or electricity, have low melting and boiling points, and are easily broken. For example, carbon is used to make lead for pencils. Metalloids are elements that can have properties of both metals and nonmetals. Silicon is used for chips and computers because it's easy to control the flow of its electricity and does not heat up as metals do.
Alright, so through the uniqueness of the periodic table, we can also see another arrangement or two. In the periodic table, there are several components we must know in order to read and fully utilize this chart. So firstly are the rows of periodic tables. The rows are the arrangement of elements that go horizontally across the chart, and not only does it show us the elements increasing by 1 atomic number, but it also shows us the number of shells or energy levels in each row. For example, the first row includes helium and hydrogen. This tells us that helium and hydrogen have only one shell or one energy level and must contain only 2 or less electrons, since the first energy level can only contain 2 electrons. This can help us in understanding reactions between two elements and how easily an element can lose or gain electrons. The second The second arrangement that we must talk about are groups or columns. The elements in the same column have the same amount of valence electrons, thus they have similar properties. As you can see, this rule only applies to the colored columns, as the elements in between, called the transition metals, are slightly weird, and they do not apply to these rules. The first column, the red one, are what we call alkali metals. The second one are alkali earth metals. They both have 1 and 2 valence electrons consecutively. They are the most reactive metals on the periodic table. The non-colored metals, as explained before, are the transition metals, which have weird electron rules and are not included in this rule. Another 2 important groups are halogen, the blue colored column, and the noble gases. Halogens are the most reactive nonmetals, having 7 valence electrons. Sorry, I forgot to clarify one thing. Valence electrons means the number of electrons on the outermost energy level or shell of an atom. The noble gases are metals that do not react, as their valence electrons are completely filled and they do not need another electron. Thus, the elements are called inert.
Then we have cations and anions.
No, cations and anions.
Cations and anions. A cation is an ion which has a positive net charge. This means that the ion has more protons than electrons. And likewise, an anion is an ion with a negative net charge. An anion has more electrons than it does protons.
Oop, just go back. Alright, so ionic compounds, as Jack explained to you before, we already know what an ion is. An ion is basically an atom with uneven electrons and protons. But an ionic compound is a compound which is held by ionic bonds. An ionic bond forms when a metal reacts with a nonmetal. The metal becomes a cation by losing electrons to the nonmetals, which gain the electrons and form anions. For an ionic compound to exist, the valence shells of all atoms pertaining to the bond must be completely filled. For this to happen, one element, usually the metal one, of the ionic compound usually must lose electrons to have filled the outermost shell. Thus, it will usually have a positive charge. Hence, the nonmetal element of the compound must have a filled valence shell, usually by gaining electrons, and it gains a negative charge. This is the way ions are formed. Here's an example: sodium and chloride. One example of an ionic compound is sodium chloride, more commonly known as table salt. We know sodium has one valence electron, as we can see over here. By looking at our columns as well, we can see that sodium has one valence electron, as it is in the first column. We also know that chlorine has 7 valence electrons by looking at its column and by looking at this diagram. So we know chlorine has 7 valence electrons and sodium has 1 valence electrons. So basically, sodium, a metal, will have to lose its electron to give it to chlorine. So chlorine can have an entire a filled valence shell, and sodium can also have a filled valence shell by losing that 1 electron, and they're
Having an even number.
and having an even number. So both electrons are happy. So once they both join together and the gaining and losing of electrons process is complete, we form sodium chloride, more commonly known as table salt.
So who discovered the proton and the nucleus? Well, most people would agree that the discovery of the nucleus and the proton can be written down to the same man, Ernest Rutherford, a scientist out of New Zealand. Rutherford is considered to be the greatest experimental scientist since the time of Michael Faraday in the 1800s. Rutherford made his first discovery in 1911 when he discovered the atomic nucleus. He was conducting an experiment in which he shot alpha particles at a piece of gold foil. During the experiment, Rutherford found that most of the particles passed through the gold foil, but some were deflected, which he said to contain most of the atom's mass, and he named this the nucleus. He also noticed that some particles bounced back, and he came to the conclusion that there's a positively charged center that was small compared to the size of the entire atom. He named this part of the atom the nucleus. Later on, Rutherford was able to discover the proton while running a similar experiment, except using neon and not gold foil. Through his findings, he was able to develop a model, which we now call the Rutherford model, which we can see here. We can see that our model is slightly different as it shows the electrons revolving around the nucleus in orbitals or energy levels.
So basically, the modern model that I had shown to you before is slightly different because Rutherford had not yet discovered that the electrons revolve around the nucleus in energy level or shells. And this is our works cited. Thank you for listening to our atomic project.
Thank you.